to touch upon the data center, how the energy management is important and what are the technologies. And also, a lot of the technologies, they are also common with the grid, whether it's utility or industry. And we can also look at from the different point of view here that how energy and digital, I always say that they are no two sides of a coin, and how the data center evolution is sort of going towards the convergence of these two. Scale of data centers coming up. Sustainability and energy transition is very important. I think all the data centers, the owners, operators, they are very um, sensitive and clear about sustainability, and that's why they are right from many of them, right from the planning stage, they are planning how it can be more green and more sustainable. Uh, that's one. Of course, we know that demand for internet, demand for AI nowadays increasing, so that is creating more and more demand on the energy side of the data center. Safety and security is very important. So these are the, of course, the other aspects, important aspects. But very important is also uptime of the data center, which also puts demand on the energy system, the power system for the data center. Whether it is the main power or backup power. So the asset as well as the system operation, they are very important in that. And many of the data center, they have also sort of declared their carbon neutral, target, net zero target. Just before getting into the data center, so how the new energy ecosystem is changing. Uh, Previous speaker already talked about, just to quickly touch upon. So the data center, they do come up in the urban areas and also the remote areas. But when they come in the urban area, there are different sources, diverse and distributed sources of energy load, different type of load. They're coming up. Whether it is the renewable power, battery energy storage, the electric vehicle, e-mobility infrastructure, and then energy management and microgrid, for each of the entities. So, and of course, the cyber security is very important in that. And for that also, the back end infrastructure in terms of feeding the power, digital substation which are becoming more and more digital. And as Hitachi Energy, we are into this space of whether it is digital substation or energy management system, SCADA, network control, network management. So uh, I would like to touch upon some of the evolving things. So just to look at how the data center is in terms of energy, the blocks. So getting the power from the grid. So you have the substation, which is very important, and then the availability of the substation. The requirement is 99.999%. So it should be available, because we know that the data, actually it should be close to 100%. So because any interruption in power can interrupt the data, and which can interrupt several millions of users, and also important applications. So here substation is very important, and then we also divide that into data hall, where you have all the data center equipment, the assets they are running. And power backup is another important area. So primarily these are the major blocks when it comes to the energy and power systems in the data center. uh, Traditionally, data center, they were basically taking the power from the utility. Of course, they had the backup generators, diesel generator, for example, which is still there also in many cases. And of course, the UPS, and of course the feeding into also the critical loads. But the modern data centers, the new ones which are coming up, they are more also on using the renewable energy, because they want to be green uh, as part of their net zero or carbon neutral target. Uh, so taking the grid power, but also having the renewable energy PPA power agreement with the generating companies. But inside the data center, of course, you have the energy storage, microgrid they do go for. um, so right now it is also mixed hybrid, maybe having diesel generator, but also the battery energy storage. But in future also hydrogen fuel cell based storage coming up. And at the same time, PV, photovoltaic, solar rooftop, they also are coming up in the data center, because they can utilize that space. And now, of course, uh, to have the energy point of view, the interruption point of view, they also have the cloud infrastructure to shift workload in case of long outage, from power point of view as well as data point of view. So these are the challenges, because that actually is driven by the need for close to 100% availability. So when it comes to data center, so what the energy, how they get it? So of course, the renewable energy from the grid, as I talked about. And but the key element inside the data center, rooftop solar, as I talked about. So that's how you get the power, utilize the renewable power, but also energy storage, battery energy storage, microgrid. But also the power quality, very important, because the data center loads, they have a lot of harmonics. And how do you do the reactive power compensation and then have the right power factor as well as energy. The monitoring and AI ML based applications which can detect anomalies in the system, predict failures. And so this is basically in combination of different type of data coming from the offline database, SCADA, in the substation, as well as online sensors, very advanced level of sensors which can actually predict any failure or malfunction in advance. And so this is called asset performance management, of course. And this also helps in identifying top failures and also spare part management. So finally, it is basically ensuring that uh, the data center uptime can be maintained. Uh, and also from the point of view of energy, it's not just the operation, having the energy and also energy efficiency, but also asset together. So that's why we also do have a control center uh, for the resilient data center, where it's a combination of asset performance management, having the sensors, prediction based on AI ML, and about the asset performance, but also the enterprise asset management and workforce management, maintenance, O&M staff, and connected to the grid, the load data, the grid data, market data, the pricing of the energy from the market, of course, the weather, because you also have, let's say, rooftop solar. So all these together in real time, they have to work. And that's how we have the real time system. Um, the SCADA as well as the asset performance management, asset and work performance together integrated, and this can actually be giving very predictable energy cost, energy efficiency also. And of course, several algorithms which are running, predefined algorithms, as well as AI ML based algorithm, basically. So it's a, again, integration, integrated network, asset and energy management also, in terms of the data center also are sort of prosumers. They are not only consuming energy, but in future they can be also storing a lot of energy, and then they can also trade with the grid, with the prosumers in that, and also they can use blockchain technology to have contract with other prosumers to exchange the energy. And these all, from the primary equipment to the automation, digital substation, to the sensor asset performance management, and SCADA and asset performance management system, asset and work together, they are integrated. And so we also have, we use digital twin, whether it is electrical infrastructure, a large infrastructure for like HVDC facts, we have done that. And similar thing also can be done for the data center power assets, basically the power equipment, energy equipment, as well as substation which can actually help in training, help in also real-time data, and also doing root cause analysis for any failure, or maybe for energy efficiency also in the data center, inside and out blocks, power, cooling, IT, building management system, as well as DCIM, that is the data center information management system. So all these, they are basically the you can say intranet of things. So they can have the same sensor extended to the cloud connectivity, or you can have additional sensors. I talked about the transformer example. So that you can have the data available on the cloud, with can be on premise or public cloud. So the efficiency, energy efficiency, as well as asset efficiency, performance, they can be sort of monitored, and then using all these digital technologies, we ensure that the KPIs can be improved. The KPIs in terms of productivity, reliability, energy efficiency, asset performance.